let's talk about nicotine and some of the ways that it affects the central nervous system. We know that nicotine causes the release of norepinephrine. Norepinephrine is also known as noradrenaline, which is a precursor to adrenaline or epinephrine. And we know that nicotine causes a release of dopamine. Remember, dopamine is our feel good, one of our feel good neurotransmitters, one of the primary neurotransmitters that's associated with the limbic system or the mesolimbic dopamine system. Okay, so activation of the mesolimbic dopamine system. What effects are associated with activation of the system? Now, if we remember from our discussions in chapter 5, okay, that activation of the mesolimbic dopamine system, that's associated with the euphoria or the reward that people experience, okay? Activation of that system is what causes behaviors to be repeated. Okay, and then when we talk about nicotine's ability to activate the serotonin system, okay, that is associated with the alleviation of depressant, it's associated with antidepressant like effects. Okay, and we say antidepressant like effects because, it produces some alleviation of depressive related effects. Okay, and so remember, we're talking generally about situational depression, etc. Smoking cigarettes is not going to have, or using nicotine containing products, let me correct myself, isn't going to have a significant effect on clinical depression. But when we're talking about our situational depression, etc., then you can have antidepressant like effects due to the activation of the serotonergic system. Okay, let's talk a little bit about nicotine's effects on the peripheral nervous system. You have nicotinic receptor sites that are located in the neuromuscular junctions, okay, of striated or what we call voluntary muscles. Okay, so again, striated muscles are our voluntary muscles. These are the muscles, they're called striated because you have white stripes, striations in them, the tendons that are in these muscles. Our smooth muscles do not have tendons, and so our smooth muscles generally are not striated. They don't have the white stripes or striations in them. And so we're talking about neuromuscular junctions, the junctions between one muscle and another, elbow joints, knee joints, things like that. That those these nicotinic receptor sites are found in those neuromuscular junctions, and so sometimes those are associated with twitches and things like that. So nicotine, by working at those junctions, can cause muscular, twitches and so forth. And so one of the things that's often observed in heavy smokers is a decreased knee-jerk response. Okay, that you don't have the same magnitude of knee-jerk response if you had a rubber pallet and hit a person at the kneecap as you would on a doctor's visit. They're not going to have the same knee-jerk reflex. Okay. Some other effects of nicotine on the peripheral nervous system, the doses of nicotine that are going to be encountered in smoking a cigarette. Some of these I will combine increased heart rate, increase blood pressure. Okay, now remember that nicotine is a stimulant. Okay, so you're going to increase heart rate, you increase blood pressure. One of the things that I don't think we've mentioned up to this point is that when we talk about increased heart rate, increased blood pressure, these are two of the effects that are associated with activation of the fight flight response as part of the peripheral nervous system. Okay, and then when we talk about those in general, it's increased heart rate, increased blood pressure. A little bit later, we're going to talk about the increased respiration. Okay, one of the other things that nicotine does is that it constricts blood vessels in the skin. Okay, so some people report that the skin of heavy smokers feels cold and clammy. I'm not saying that every smoker feels cold and clammy, but this is one of the observations that's been made. And so that blood vessel and skin temperature thing are related, that nicotine constricts the blood vessels of the skin. And because the blood vessels of the skin are constricted, the temperature is lowered. The person's skin temperature is lowered. So you've got increased heart rate, you've got increased blood pressure, you've got constriction of blood vessels in the skin, and you've got decreased skin temperature. Okay, now let's talk about some of the effects of nicotine on the stomach. Nicotine actually inhibits stomach secretion, and by inhibiting the stomach secretion, that causes the individual to feel nauseous. Okay, usually the presence of stomach secretions in there, keeping everything modal and moving, keeps the individual, keeps that environment at peak condition. Okay, but nicotine inhibits stomach secretions, thereby causing nausea. Okay, at the same time, nicotine can increase the activity of the bowel. So if you want to call it bubble gut, so to speak. So you're inhibiting stomach secretions, which makes an individual feel nauseous, but you're increasing activities of the bowel, which causes, the bubble gut syndrome. Okay. One of the things that happens is that tolerance develops to these effects. So in your experienced smoker, a continuing smoker, these effects are not as pronounced. But even a seasoned cigarette smoker, if they smoke too many cigarettes, they can still feel nauseous or still smoke enough to make themselves sick. Okay. Some other effects of nicotine on the central nervous system. We know that nicotine causes the release of epinephrine. Okay, that causes arousal in the central nervous system. Okay, one of the things that I think few people are aware of is the effects of nicotine on respiration. Nicotine actually has the ability to increase respiration. Now, the important thing to understand here is that we are talking about the nicotine molecule. The nicotine molecule, nicotine itself, can increase respiration by stimulating the medulla. Remember, the medulla is the area of the brain that's responsible for the depth and the rate of respiration. So the nicotine molecule can stimulate respiration, okay? But you're not likely to experience or see those effects because of all of the things that smoke itself does to respiration, okay? And so a lot of times when you talk about the effects of the drug, what's difficult for some people to do is to separate out what the drug itself is doing versus other ingredients or components that might be involved in the equation. And so the nicotine molecule itself can stimulate respiration, but we know that overall, smoke and all of the components that are part of smoke decrease or interfere or impair respiratory processes. Okay, so I just want to make sure you are able to separate those two, what the nicotine molecule itself can do versus all of the crappy stuff that smoke and its ingredients, tar and all the other things can do. Okay, in terms of central nervous system arousal, we know that nicotine can also stimulate the area of the brain that's associated with vomiting. Okay, so remember on the previous slide, we said in the peripheral nervous system, outside of the brain, outside of the central nervous system, the brain and the spinal cord, we talked about what it can do to stomach secretions and bowel activity. Okay, that's outside of the central nervous system. But in the central nervous system, in the brain, it can stimulate the area of the brain that's associated with vomiting. Okay, and here the effect is going to be most noticeable in non-smokers. Why? Again, this is because tolerance develops pretty quickly to this effect. But remember, even in the seasoned smoker, if they smoke too much, then they can still become sick from smoking. Okay, so we'll stop here, and when we pick up, we're going to talk about some of the theories that try to explain why people smoke.